All right, students, this is lesson 5-9. I need you to get your pages tore out of your book, 321 through 325. We're going to be using conversion factors and converting within the metric system today. So we're going to change metric to metric. Some size of metric to another size of metric, like we did yesterday, only we were in the U.S. customary system yesterday. All right, so on your solve and discuss it, Sam needs to fill a 5-liter water jug. Here's the water jug for his team. If he uses the water bottle, and if you look at the water bottle, it holds 250 milliliters. Milliliters are little bitty. How many times does he need to fill the water bottle to fill the jug? So we need to know how many of these will fit into here. All right, so here we go. We're going to change we're going to change 5 liters, and if you look at liters, it's a capital L. So 5 liters, and we're going to change that into milliliters. And right here on the top it says there's 1,000 milliliters in 1 liter. So here's our conversion factor. 1 liter has to go in the denominator because these have to cancel. This half has got to go down here. This 1,000 milliliters, now that's a lowercase m and an uppercase L for a correct abbreviation. All of these things are important. So now that tells us that when we do this, we get 5,000, 5 times 1,000 is 5,000 milliliters. Milliliters, capital L. Okay? Now then, if this bottle holds 250, I need to take this 5,000 milliliters and divide it by 250 milliliters to see how many times it will go in there. So what is 5,000 divided by 250? And the answer is 20 times. Now, 25 goes into 52 times, and then these zeros, we'll put another 0 on there. You can do that in your head. Okay? Now, look at the math practice down at the bottom. It says how many liters of water does Sam's water bottle hold? So we're going to take 250 milliliters and we're going to change that to liters. So this time the 1 liter's got to go on the top and the 1,000 milliliters, same fact, but it's upside down to what we used a while ago, has got to go on the bottom because these have to cancel. Not the numbers, just the units. Okay? So my answer is whatever this fraction is reduced in liters. Well, those zeros cancel, and 25 over 100 is a fourth. 25 goes into 25 one time, goes into 100 4 times, so that's 1/4 of a liter. If you do that with your calculator, it will look like 0.25 liters. These are the same answers. Okay, so we're doing the same thing we were doing. We're going to use facts. These are all facts. They're called unit multipliers, conversion factors. Unit multiplier is the same thing as a conversion factor. Sometimes they use one terminology, sometimes they use the other. These are unit multipliers. And I can't keep from saying it that way because that's the way I learned it. Or they're called conversion factors. This is really better because factors are multiplied together, and that's what we do to change from one thing to the other. We multiply it by what we need to turn it into what we want. We take what we have, we find a fact, we use it correctly, to cancel out one unit to turn it into a different unit. It's like magic. All right, let's go to example 1. Amelia is helping her father build a skate ramp. They cut a board 1 2/10 meters long to use as the back of the ramp. Is the length of the board as shown in centimeters correct? Well, let's see. If I had 1 2/10 meters and I wanted to change that into centimeters, where's meters and centimeters? Right here. So I want the 1 meter part in the bottom. I want the 100 centimeters in the top. Now meters are gone and my answer is going to be in centimeters. What is 1.2 times 100? Well, when we multiply by powers of 10, it moves our decimal 2 places over, so it should be 120 centimeters. So yes, it's correct. That's what they have right there, is 120 centimeters. Okay? They show you how to do it right here. You can do it using dimensional analysis or using equivalent rates. Same 2 ways that you saw when we were doing U.S. customary systems. All right. Let's go on to example 2. Look at example 2. You should always look at the examples in your book. They're good. Convert metric units of capacity. Remember, capacity is how much something holds. Here's your units of capacity. We need anchor charts for all of these things, and you need to start getting these things memorized. Okay? Some of them anyway. This is one I would memorize. This is one I would memorize. Some of these others, I don't memorize those. I memorized the basic ones. Okay, so Raji poured 150 liters of water into an aquarium. How much more water does Raji need to fill the aquarium? This is how much it holds. Okay, so right down here, he said, here's how much it holds, and we're going to see how much that is in liters, and then he is already, here's how much it holds, and here's how much he's already put in, he poured in, and this is how much he still has to put in. I like this way much better. Here's how much it's going to hold right here. I just think that it looks more straightforward, and I just do it the same way every time, over and over and over and over. Okay, so that was it with capacity. Now we're going to the kitchen. Example 3. Lyle has a bowl that contains 0.8 of a kilogram of salt. He uses a spoon to remove 850 centigrams of salt. How much salt in centigrams remains? So he starts with, I'm going to go right down here. All right, my apologies. I got interrupted. Okay, so I'm going to leave that right there for you to look at, or your teachers to look at, and I'm going to come right down here and I'm going to do it my way. I'm going to start with the 0.8 kilograms that I have. And if you look at your, let me move that back down just a little. If you look at your metric units of mass right here, here's kilograms. Kilograms goes to grams, and that's one I have memorized. I know there's 1,000 of the smaller ones in the one bigger one. So I'm going to put that in next. In the one big one, kilo's always big. One big one, there's 1,000 of the smaller ones. And that gets me to grams. Then I'm going to look up here, and I want to go to centigrams. So here's grams and centigrams. And the prefix cent, C-E-N-T, centi, means 100. So I know there's 100 of these in one of these. Like there's 100 pennies in a dollar. That's why we call them cents, 100 cents. Okay, so I want my gram down here, my 1 gram, and I want my 100 centigrams right here. Now I've gone from kilograms to grams, and then grams to centigrams. Now, if you have a calculator, just sit down and punch this in. I want 8/10 times 1,000 times 100. And when you do that, you end up with 80,000 centigrams. And I like this all in one row like this. Now then, if you read go back and read it, it says that he used a spoon to remove 850 centigrams. So now let's subtract 850 centigrams from that, and it says how much remains. Well, it's 79,150. 0 from 0, I've got to come over here and borrow. 9, 9, 10, that's 5, that's 1, that's 79,150 centigrams. And there's your answer. Same thing they got over here, just done my way with dimensional analysis. Now, you see right here where it says look for relationships? You could also convert kilograms to centigrams using dimensional analysis. This is what we did right here, was dimensional analysis. Okay? All right. Turn your paper over and let's look at our key concept. Now I'm showing you how to do this the same way we did the U.S. customary. Same way. All right, you can convert metric measures by finding an equivalent rate or by dimensional analysis, and again, that's the one I prefer. So this one right here is the one I prefer, and they use a time sign where I use parentheses. It's the same thing. An X for a time sign. I don't like an X for a time sign. Okay. Let's look at let's look at number 2. I want you to see the prefix. How are the metric units of kilometer and kilogram the same? The prefix is the same. And the prefix means it's 1,000 times bigger than something. So kilo means 1,000 times larger than the base unit. So there would be 1,000 grams in 1 kilogram. There would be 1,000 meters in 1 kilometer. Kilo means it's big. Okay. Let's look at number 3, which is bigger, which is greater. Well, you can't compare when they're different, so you got to change one of them. So let's leave this one. It's in a whole number. Let's take this fraction, or decimal, this 0.25, which is 1/4 kilometer, and let's change it to meters. Now, what did we just say? We said in 1 kilometer, there's 1,000 little ones. So there's 1,000 meters in 1 kilometer. Okay? Because this is 1,000 times bigger than one of those. All right. So I got to move this 3 places. 1, 2, 3. So that would make that 250 meters. So which is greater, 250 meters or 250 meters? So you should say neither. They are the same. Okay, we just proved it. Okay. Let's look at number 4. how can you find the conversion from milliliters to kiloliters? So I got to go milliliters to the next size up. So I'm going to go milliliters to liters. So I'm going to go milliliters to liters. And then I'm going to go, comma, then I'm going to go liters to kiloliters. This is the smallest, this is the biggest. And I'm just going to climb my way up. Okay, go back to number 1. So, we're going to use dimensional analysis. Big words, but not hard. How can you use ratios to convert metric units? We're going to start with something, and then we're going to keep multiplying until we get what we want. This is called dimensional analysis. Okay, that gets us to number 5. What is the conversion factor when converting from liters to milliliters? Remember, this is bigger than this one. The milli means very small. Okay, so there are 1,000 milliliters in 1 liter. You can write it like that. You can write it like this. You can write it like this. But the 1,000 has to be on the milliliters, that or that or that. They all mean the same thing. And you're going to use them as needed. Now, on number 6, it specifically asks us to use equivalent rate to convert 35 centimeters. Okay? Centimeters to meters. So I'm going to start with my conversion factor. There is 100 centimeters in 1 meter. Now, I want to convert 35 centimeters to meters. So we want this up here to be 35 centimeters. Okay? So what do I have to do to this to get that? Well, I actually have to multiply by 0.35. By 0.35. So when you get finished, you get 35. What is 100 times 0.35? It's 35. And what is 1 times 0.35? It's 0.35. Okay, so there's your answer doing it that way. I don't like that way. I like dimensional analysis better, but it specifically asks us to do it that way. All right, let's look at number 7. Maddie wants to know how many centigrams are in 75 hundredths of a gram. She converted 75 hundredths of a gram to its equivalent in centigrams as shown. Oh, no, she didn't, because this fact right here is incorrect. So, no, that should be 100 centigrams in 1 gram. So, no, she used an incorrect conversion factor. You don't get to just make those up. You have to use the facts. All right, let's look at number 8. Dimensional analysis. Yay! My way. 0.75 grams. We want to change that to centigrams. So I need to know the fact from grams to centigrams. Well, let's go find it. Centigrams to grams. centigram, that's meters. It's on the back of this one, I think. Centigrams to grams. Remember, centi means 100. These are little. So if there's 100 of these in one of those. Okay, what did we just say? We said in one of these, there's 100 of these. So the 1 gram has to go on the bottom. So they cancel out. Now, when I take 75 hundredths and multiply it by 100, I just get 75 centigrams. 75 centigrams. I just like this method so much better. Okay, we're just going to spend one day on this. You don't have too many questions on your midterm on metrics, but we got to practice some. So your job with your classroom teacher is to practice in problem solving. You also have a reteaching and a vocabulary page you can work on. So you have 3 things to work on. This is only about a 21-minute video. So you have lots of things to work on in class by yourself or with your classroom teacher. So let's practice using dimensional analysis and see how good we can do on the metric system. You have all of your information in on your pages. You have units of capacity, units of mass, units of capacity, units of length, units of mass. Hopefully you have anchor charts up somewhere on all of these, and you're learning some of them, learning your prefixes, and so you look all those things up while you're working on your practice and problem solving, vocabulary, and reteaching page for 5-9. And I'll see you next time.